Q8406-2. A loss of tail rotor effectiveness, LTE, is a condition that occurs when a. The flow of air through a tail rotor is altered in some way. b. The flow of air through the main rotor is altered in some way. c. Power to the tail rotor is substantially reduced or lost. The correct answer is A. Loss of tail rotor effectiveness, LTE, is a phenomenon that occurs when the flow of air through a tail rotor is disrupted or altered, leading to a loss of the tail rotor's effectiveness in providing the necessary anti-torque or yaw control for the helicopter. LTE is most commonly encountered during certain flight conditions, such as high power demands, high angles of bank, and high rates of descent. These conditions can cause the main rotor's downwash airflow to interact with the tail rotor, leading to flow disturbances or disruptions. Some factors that can contribute to the alteration of airflow through the tail rotor and result in LTE include ineffective tail rotor thrust due to inadequate power or loss of power to the tail rotor, disturbed or turbulent airflow from the main rotor, which can occur during high power demands or aggressive maneuvers, aerodynamic interference from the fuselage, vertical stabilizer, or other components, which can disrupt the airflow to the tail rotor. When LTE occurs, it can lead to an uncommand yaw or loss of yaw control, potentially resulting in a dangerous situation for the helicopter. Pilots must be aware of the conditions that can lead to LTE and take appropriate actions to prevent or recover from it. Therefore, LTE is a condition that occurs when the flow of air through a tail rotor is altered in some way. Q8408. The lift differential that exists between the advancing main rotor blade and the retreating main rotor blade is known as A. Coriolis effect, B. Dissymmetry of lift, C. Translating tendency. The correct answer is B. Dissymmetry of lift refers to the lift differential that exists between the advancing main rotor blade and the retreating main rotor blade in a helicopter. It is a result of the different aerodynamic forces experienced by the blades as they rotate through the air. As a helicopter's main rotor blades rotate, one side of the rotor disc is advancing into the oncoming airflow, while the other side is retreating and moving away from the airflow. This creates a difference in the relative airspeed and angle of attack between the advancing and retreating blades. The advancing blade experiences a higher airspeed and generates more lift, while the retreating blade experiences a lower airspeed and generates less lift. This difference in lift production between the blades is known as dissymmetry of lift. To compensate for dissymmetry of lift, helicopters incorporate design features such as blade flapping and cyclic control inputs. These mechanisms allow for the adjustment of individual blade pitch angles to equalize lift and maintain rotor stability during flight. Coriolis effect, on the other hand, refers to the apparent deflection of a moving object due to the rotation of the Earth. Translating tendency is a phenomenon where a helicopter has a natural tendency to drift laterally during forward flight. Therefore, the correct term for the lift differential between the advancing and retreating main rotor blades is dissymmetry of lift. Q8409. During a hover, a helicopter tends to drift in the direction of tail rotor thrust. What is this movement called? A. Translating tendency. B. Transverse flow effect. C. Gyroscopic precession. The correct answer is A. During a hover, a helicopter tends to drift in the direction of the tail rotor thrust. This movement is called translating tendency. Translating tendency occurs due to the asymmetrical thrust produced by the main rotor and tail rotor. In a hover, the main rotor generates lift and produces a torque that wants to rotate the helicopter in the opposite direction of the rotor's rotation. To counteract this torque, the tail rotor produces thrust in the opposite direction, providing anti-torque to maintain the helicopter's heading. However, the tail rotor's thrust also causes a lateral force that tends to push the helicopter in the direction of the tail rotor thrust. This results in a tendency for the helicopter to drift sideways during a hover. The pilot needs to use cyclic control inputs to counteract this translating tendency and maintain a stable hover. Transverse flow effect is a phenomenon that occurs during low-speed flight or hover where the rotor's advancing blade experiences higher relative airspeed and lift, while the retreating blade experiences lower relative airspeed and lift. This leads to a lateral flow of air across the rotor disc and can cause asymmetric lift distribution. Gyroscopic precession is a characteristic of rotating bodies, such as the main rotor of a helicopter. It refers to the deflection of a force applied to a rotating body 90 degrees later in the direction of rotation. In the context of a helicopter, gyroscopic precession is relevant when considering the effect of cyclic control inputs on the rotor's tilt or pitch. Therefore, the correct term for the movement of a helicopter drifting in the direction of tail rotor thrust during a hover is translating tendency. 8410. What is the purpose of the lead lag, drag, hinge in a three-bladed, fully articulated helicopter rotor system? A. Offset lateral instability during autorotation. B. Compensate for Coriolis effect. C. Provide geometric balance. The correct answer is B. A three-bladed rotor system's rotor blades flap forward, accelerating the blade as the blade's center mass approaches the axis of rotation. The blade decelerates, or slows down, as it flaps downward because the center of mass shifts away from the axis of revolution. The Coriolis effect is the name given to the rise and fall in blade velocity in the plane of rotation caused by mass movement. In a three-bladed system, the leading and trailing acceleration and deceleration motions are absorbed by dampers or the blade structure itself, hinges. 8411. During an autorotation, collective pitch full down, what is an increase in rotor RPM associated with? A. An increase in airflow through the rotor system. B. A decrease in airflow through the rotor system. C. A decrease in airspeed. The correct answer is A. During an autorotation, when the collective pitch is fully down, the helicopter's rotor RPM is primarily controlled by the airflow passing through the rotor system. As the collective pitch is lowered, the angle of attack of the rotor blades decreases, reducing the drag and allowing the rotor to freewheel. To maintain rotor RPM or prevent it from decaying too rapidly, it is essential to have sufficient airflow passing through the rotor system. This airflow can be achieved by descending at an appropriate rate or by utilizing any available sources of upwash, such as wind or the downwash from the helicopter's own descent. An increase in airflow through the rotor system helps to drive the rotor, leading to an increase in rotor RPM during an autorotation. This increase in RPM is necessary to maintain rotor energy and sustain rotor authority, which allows the pilot to control the helicopter during the descent. A decrease in airflow through the rotor system would have the opposite effect, potentially leading to a decay in rotor RPM and reduced control effectiveness. A decrease in airspeed can be a consequence of the autorotation, but it is not directly associated with an increase in rotor RPM. The primary factor influencing the rotor RPM during an autorotation is the airflow through the rotor system. Therefore, during an autorotation with the collective pitch fully down, an increase in rotor RPM is associated with an increase in airflow through the rotor system.